Now in this video we're going to focus on the part 2 of the migratory insertion, which is the link between oxidative addition and reductive elimination in a specific cyclic organometallic catalytic reaction. So in this particular part, let's just do a little bit of a refresher on what we talked about on our previous video. We have a specific ligand, which is in this case X, and X, what happens is that it bonds initially with a metal and it sees to another ligand called Y. What happens first is that we have a migratory insertion happening, where as a result of this particular reaction we actually have our metal bonding to our Y and Y bonds to the X. Now this particular complex created is actually not a saturated complex. So what happens is that we actually have a specific extra ligand floating around this particular solution, and what results in is the insertion, which is facilitated by this particular ligand attached to the metal, and what results in is the ligand bonding to the metal, and the metal bonds to the Y, and Y bonds to the X, therefore making this particular complex here that is formed to be a coordinative saturated complex. Now that is out of the way, we're going to apply this particular concept to a focus case where we have carbon-palladiation of a complex. In this case we have this particular complex, and this complex will be performing a specific migratory insertion reaction in the presence of alkene, which is located in this particular region of this particular compound. So let's focus on this particular complex. Now this complex already has performed a specific reaction called oxidative addition, where we have a specific ligand here, which is phenyl attached to the metal cis to iodide. So now that is, in this case we have this particular overall complex to have 16 electrons in terms of the total number of electrons there, as a result of palladium having a charge of +2. Therefore this particular complex is actually active, and it's ready throughout this particular reaction process to perform migratory insertion and things to follow. Now first off, we need to create an empty site for this reaction to happen, and to do that we have a really good leaving group. In this case is phosphine, and phosphine here is going to be leaving to actually give room for this particular ligand. We usually indicate that with this box, and then we have our other part here, which is a phenyl group still present in here. So what's going to happen next is that this alkene portion of this particular compound will actually coordinate with this particular metal site right there, which is shown as this, where we have the R phenyl group actually positioned cis to this particular new ligand that is introduced right there. Now this is formed, we actually perform our migratory insertion reaction, where we actually have this bond actually forming a sigma bond with the carbon right there, and then this pi bond actually forms a sigma bond with the carbon on the phenyl group right there. Therefore this results in the intermediate step, I will call it. In this case you notice that there is an empty spot right there. To make this particular empty spot to be saturated coordinatively, we introduce back our phosphine, which actually comes back and fills that particular spot up. So we actually have our side product, thereby making this overall complex to be coordinatively saturated. So The next step that happens usually is a beta-hydride elimination reaction, and what that means is that there is a beta carbon that actually has hydrogen, and the hydrogen here, what happens is that it performs some kind of elimination of the hydrogen that actually makes the hydrogen to bond to the metal and then cleaving off a particular bond to form a pi bond. So what you notice here is that this hydrogen that is positioned right here actually bonds with a particular metal, and this bond here cleaves and forms a pi bond that results in a hydrogen bonded right there, and then we have our phosphine which is positioned right there, and then we have our leaving group. So this is actually the process that is called the beta-hydride elimination reaction, and this beta-hydride elimination reaction can be noticed using the Newman projection, where on this part here we have, I will just put metal that is bonded with phosphine, two of them with iodide, and we have Cr right there. I'll just put it as an R group, and here we have hydrogen, here we have hydrogen right there, and in the front carbon we have a phenyl group positioned right there and a hydrogen right there. I'll try and make the back of this particular structure to be the same on this other side. However, there will be a slight change at the front on this part right there. So at the front we have our hydrogen, but we have our phenyl group that is positioned at the other side, and we have hydrogen positioned right there. So looking at the Newman projection, due to the steric hindrance happening right here at this site, we actually have the direction of our reaction going in favor of this way rather than that way. So what's going to happen is that we're going to have this bond actually cleaving and forming a pi bond right there between the circle, which is this carbon, and this point right here, which is a carbon, and then we're going to have this hydrogen cleaving off to form a bond with the metal. So that's about it for this particular reaction that is actually occurring in a specific carbopalladation of a complex in the presence of alkene. There is usually a further reaction in here due to the presence of a base that actually results in the change in the oxidation number of our palladium from 2 back to PD0, and that is due to the fact that this hydrogen and iodide, they form due to the process called reductive elimination. You can perform that at home for practice, will actually result in the formation of this, and we have iodide with the hydrogen right there. Sometimes you can actually, in the presence of the base, make this particular iodide to coordinate with the base, which is what you have right here, where we have a specific amine with hydrogen and iodide. That's about it for this particular video. Hope you're able to understand the big part of this particular reaction, which is this particular step that shows this particular known type of reaction to be called the migratory insertion, not only in this step but also coming down here, and how this is crucial in this type of chemical reaction that is an application. All the same, stay smart and believe in yourselves.